We're going to sidestep for just a minute and talk about something that is going to come up over and over again throughout the course, and that's the idea of carbocation rearrangements. You've already learned that if you protonate an alcohol, that you are giving the species a good leaving group where this can come off as water. And so if it's a tertiary alcohol like this, that's going to form a carbocation. And this tertiary cation is very stable. However, if you protonate an alcohol like this and the leaving group comes off, it leaves behind a secondary carbocation, which is less stable. What can happen is the following. You start with a secondary cation, and on a neighboring carbon, a hydrogen picks up its sigma electrons and moves next door. And this leaves behind a positive charge on the tertiary position, so now you have a more stable cation than what you started with. This type of carbocation rearrangement is called a 1,2 hydride shift. The 1,2 comes from the positioning of the two carbons relative to one another, and the hydride comes from the fact that it's H moving its two electrons with it, so you can think of this as a hydride. So say you have this alcohol and you want to run the reaction that we learned about in the previous video, converting the OH group to the X, and at that position. You're actually not going to be able to get that product, because what's going to happen is it's going to rearrange, and so no matter how hard you try, the X group is going to come in primarily to this position here. The other type of rearrangement that can occur is this one here. And this time a methyl group, or it could be even a larger alkyl group, will pick up its sigma electrons and move over. And again, this leaves behind the positive charge at the tertiary position. And this is called a 1,2 alkyl shift. Now, since I showed it with a methyl group, this specifically would be a 1,2 methyl shift. But you could see this with an ethyl or a propyl or any other R group, and so the generic term is an alkyl shift. And so if we started with this alcohol, tried to run this reaction, no matter how hard we try, we would never get the X group coming in here. It's always going to make its way over to here. The bottom line is, if carbocations can rearrange, they will. And so we always have to watch for this with reactions that involve carbocation formation, and particularly with a secondary carbocation, because tertiaries will not rearrange. They're already very stable, and primaries don't really form in the first place. And so we're really talking about when you have a secondary carbocation, if it can rearrange via a 1,2 hydride or a 1,2 alkyl shift, it will.